Hello, today we're going to talk about linear regression in algebra and do a couple examples about that. So basically regression is just kind of like going backwards is kind of what it means. But what we're going to be talking about is data where, if everything we've done so far, we've had points that lined up perfectly like this, right? Those points are linear. They line up beautifully and perfectly. What linear regression is talking about is when maybe your points aren't perfectly lined up, but the general overall pattern would be linear. If you kind of made an average, which is what linear regression is, where all the points, the average spacing is equal, this is linear regression. So in real life and real data, it's not as common to get something beautifully linear as it is to get something that has a linear pattern but may not be perfect. So to do this, we're going to actually use Desmos to help us. You can also do this in the TI-80 whatever calculators. And it's not very difficult, but I like Desmos better, and that seems to be the way we are all moving. So the first thing you want to do is write the equation for the line of best fit for this data. All right. So I'm going to have this data here, and I'm going to type it into Desmos. You're going to see that on the screen, so this will go away. Or maybe not, actually. Let's try it like this. Let's put on Desmos, which is right there, and maybe we'll put the camera in front smaller, and that way you can see what I'm doing. All right, perfect. We're going to follow these directions. So first we're going to go over here and we're going to click the plus sign. When we click the plus sign, it says to choose table. So we're going to choose the table, and then we're going to type in that data. Apparently, as I type, this is going to disappear. So I'm going to look at my paper, but you're not going to see it for a moment. All right, so our data is about the age of players and how many are playing lacrosse, I guess in a league or something like that. So one thing that's important to remember is which is X and which is Y. X is usually the one on the right or the top, and Y is on the bottom. Y is dependent on X, so X is independent. Their age is independent, and then the number of players depends on how old they are. All right, so I'm going to go ahead and type this into my chart. All right, oops, I don't want that. Okay, there we go. And the Y values, there's 17 players at 13 years old, 14 14-year-olds, 6 15-year-olds, 9 16-year-olds, and 12 17-year-olds. All right, now we can't see anything on our graph, but you can, if you go over here to the minus and zoom out, you can start to see our graph. Now, this doesn't look super linear to me, but I guess it does. Maybe it's negative going down. And you can see the data isn't perfect. So if you go back over here and you look at the instructions, which feel free to write them down, we've done number 1, number 2, and number 3. All right, so now we can see what the data looks like. The next thing in the next box, you need to type, this is the regression formula for a linear regression. Now, if you look over here, you see this says x1 and this says y1. So in your equation, you're going to have y with the 1 and x with the 1. And I'll show you how to type that in. It's important that you put those there, but what's even more important is that it matches this. So for example, if this said x with a small 2 and y with a small 2, then your equation, when you type it in, will have 2's so that it references the right table. All right, so I'm going to go ahead and type that in. I say y1, and if you just type 1, it puts it as a subscript. Squiggle, which is up here, squiggle, m for slope, x1 plus b. All right, so you can see that as you type, Desmos draws a line into your picture, and you can see how it fits pretty nicely. These two are pretty close. Those two are pretty far. This line is an average of those 5 points. All right. Just in case you don't have a keyboard to type on, you can also show the keypad right there. See it? All right, I'm going to hide that again. Now, the next thing that it says to do is to write down the equation by substituting for m and b. And you can see right here, we have m and we have b. So we're going to write y equals negative 1.5 x plus 34.1. Now we're going to actually talk about what that data means, all right? So this is where regression lines are kind of interesting. First of all, this negative slope, what that means is that as the kids get older, fewer are playing. That's what that means, okay, because it's negative. If this was positive, it would mean that as people get older, more are playing, okay? This is the y-intercept. The coordinates of the y-intercept you can see on the graph. The coordinates of the let me move my graph a little bit. All right, there we go. The coordinates of the y-intercept are 0 and 34.1. Remember, x stands for age. 0, 34.1. That means that at 0 years old, there are 34.1 lacrosse players. Does that make any sense? No. And so this data is only as good as the place where it makes the most sense. All right. So at 0 years old, there are 34.1 lacrosse players. And similarly, if you look over here at the x-intercept right there, then what that's saying is that at 22 years old, nobody plays lacrosse anymore. All right. So some of this data is not perfect, but it kind of helps you understand how it would work. And I wrote up here, use your equation to predict how many lacrosse players are 24 years old. You would substitute 24 for x, and I'll do that over here to the side. So you would have y equals negative 1.5 times 24, that's the age, plus 34.1. Now I made up that question, and obviously if you look over here at 24 years old, there are not very many. There's negative players. But for right now, let me pull up Desmos on my phone. We're just going to type it in so you can see what that would look like. So I'm going to type in negative 1.5 times 24 plus 34.1. So this is saying that there's negative 1.9 players at 24 years old. So you can see the data is kind of weird, but we could still answer the question. All right. I'm going to do 4 more examples actually, so this video will be a little bit long, just because I want to make sure you really understand regression. All right. One cool thing about Desmos that I do want to show you is that you can use it not even just for regression, but for writing the equation of a line. So I'm going to clear my table. Let's see. I don't know if I can clear them all. Let's see. We'll just go here and backspace. There we go. Okay. And we're going to start now by filling in these 2 points, negative 3, 4, and 5, negative 7. Negative 3, 4, and 5, negative 7. All right, so this, I'm going to go back to home so we can look at it a little bit better. This is what this line would look like. What is the equation for negative 3, 4, and 5, negative 7? So what we're going to do is we're going to substitute these numbers in. So y equals negative 1.375 x minus 0.125. This is the equation for a line passing through the points, negative 3, 4, and 5, negative 7. Now you can also look over at here, these numbers here, they mean how close it is. So you can kind of watch this number and you'll see how close it is. These fit perfectly. They cross through both points. Nothing is over to the sides. So that means it's a perfect fit, a line of best fit. This one fits perfectly. Okay? All right, let's do number 2. We're going to clear our table again. And we are going to type in this. This time we're talking about golf scores. This guy played golf for 4 weeks, and this is his score. So if you look at this, you might assume, looking at those numbers, see how they're all just getting smaller and smaller and smaller? So what that means is that we should have a negative slope. But let's check. So we're going to enter in our weeks. 1, 2, 3, 4. And now we're going to enter in our scores, which I'm going to take from my paper. All right, and now look, we cannot see any data over here. Nothing. So I'm going to just move around, and I'm going to zoom out. There it is. There's our data. Now I really like to be able to see the x and y intercepts if possible. Let's see if I can zoom out a little bit more. I'll go back. All right, you can see here's where our data is clustered, way up here. And we were also right. It's a downhill line. The slope is going down. Okay, so we can use this. It's already still typed in from before to write out our equation. Let me pull camera back. So the equation would be y equals the slope over here, negative 4.1x plus the y-intercept, 116.5. This is the equation for the line of regression, the regression line. What this means is that as the weeks go on, his score gets lower. I think that's what you want in golf. I'm pretty sure that's what you want, is a low score. So that's a good thing, that his score is going down as he practices. The y-intercept means that the first time, or the 0 time that he played, he would have scored 116.5. We all know that you can't score any points if you haven't played. And so this data is just kind of a starting point. Another cool thing to think about is that the x-intercept right here, see if it'll let me, this x-intercept means that after 28 weeks, he would have a score of 0. We also know it's impossible to have a score of 0 in golf, because if you swing the club even once, then you have a score. And so it doesn't really make sense down here. It also doesn't make sense up here. But this data shows a downward trend, and that's what's important. Now, on our worksheet, it says, what would the score be after 10 weeks? All right, so you're going to substitute 10 in for x. All right, so that's going to be negative 41. Oh, right over here, negative 41 plus 116.5. And we can use Desmos to do that. I'll just make a new box. Negative 41 plus 116.5. So after 10 weeks, you would expect to have a score of 75.5. Which you can't see because the little camera thingy is in the way. All right, right there. Another thing that you could do if you wanted to, and just to review a little bit more, is you could type x equals 10, because the number of weeks equals 10, and it will tell you, it'll draw a vertical line, and that intersection point, 75.5, is the answer. All right, so if you wanted to know maybe what your score would be after 15 weeks, x equals 15 weeks, and you can see your score would then be 55. All right, does that make sense? I hope so. All right, feel free to try the next one on your own and then come back, but I'm going to obviously go through it just in case anybody needs to. I'm also going to do this thing where I accidentally just delete my table, okay? So I'm going to follow directions and open a new table by clicking the plus table. Oh, it still says X1, Y1. Okay. All right. So I'll mess that up a little bit later then. So this time we're talking about soil acidity and how many bushels are harvested. So we're going to see if we can figure out what the proper acidity is. What would be the best acidity for soil to get the most bushels out of it? Is it a higher acid soil? Is it a lower acid soil? That's what we're looking for. So again, this part is going to disappear when I click over to type in Desmos, but I'm going to just type this chart. Of course, this soil acidity being the X and the number of bushels depending on the soil acidity being Y. Definitely looks like lower acidity is not a good thing for this soil. All right, so see how these look fairly linear? And we want to find the equation. So we're going to type in y1 squiggle, m for slope, x1 plus b. It gives this to us, and look at this. See how it's crossing through those points so nicely? It's a little bit wobbly, but that's why this R number is so high. It's really close to 1, which means this is a really great line. Okay, we're going to write down the equation for the line of regression. Y equals 52.69 x minus 300.46. All right, again, that data came from right here, the slope and the y-intercept. All right, and I didn't ask you to predict anything on this one. So let's just look over here at the graph and just talk about what it means again, and then we'll move to number 4. All right, the y-intercept, woo, it's way down here on this one, somewhere around here. Where is it? There it is. The y-intercept is negative 300.455, which we knew from our equation. And what that means is that when the soil acidity is 0, then you would get negative 300 bushels. Obviously, you can't get negative 300 bushels. And so while this is important, it's also something that doesn't make sense, so we kind of disregard it. The x-intercept says, which is a little bit more interesting. I'm trying to click on it, but it's not really letting me. Anyway, it's right about there. And what it's saying is that when the, why can't I find it? Come on, there we go. There's the x-intercept. The x-intercept is saying that when the soil acidity is 5.702, so a little bit higher than that, when it's 5.7, you won't get any bushels. So 5.7 is really the bottom acidity you could possibly get to harvest anything. The higher the acidity, the more bushels that you'll harvest. All right, I hope that you're finding this interesting. I think it's really cool. I'm going to go down here and I'm going to add another table just so I can kind of show you what might happen. All right, do you see on this table it says x2, y2? We're going to have to keep that in mind and be very careful about it. All right, the next question I actually put about COVID-19 because I want to talk about that, and also because it's COVID-19 right now. And what I'm going to want you to see is something that leads into another topic, but let's kind of take a look. All right, we're going to type in the information from this chart. On the first day that there was COVID-19 in the United States, there were 225 cases. So I'm going to take a second to type this in. Oops. Okay, so I have it all typed in and you can see absolutely nothing on our graph because look at these numbers, and so we need to zoom out until we can see them. Hey, there they are. Why are there only 3? Maybe they're all smushed together. Let's see. Oh no, let's see. There's another one. All right, so these are really hard to see because they're really, I think there's even more. There it is. They look like a straight line up and down on 0, which is kind of funny. And it makes it kind of a little bit harder to explain it to you. But that's all right. So these are all kind of wobbling right around that line, but that's kind of got a big impact. So maybe it will make more sense when we type in our line of best fit. So in the other ones, we typed Y1, but do you see how this says Y2? So we're going to do Y2 squiggle this time. So it knows which chart to look at, MX2 plus B, and it gives us our line. Now, something super important to look at are these numbers right here. See how they are significantly further from 1 than they were before. All right, and that's because this is actually an exponential growth pattern, which means something you'll learn more about in Algebra 2, but I kind of wanted to see what it would look like so we could get a feel for it on here. All right, let's write down our equation for the line of best fit, or line of regression. Y equals, over here, 721.9x minus 2192.3, 2092.3. All right, so let's talk about what this means. This means that on day 0, there would have been negative 2,192 cases. Obviously, that's not true, okay? It also means that, that I just totally lost my train of thought for a second. I'm sorry. All right, so what it means is that if we wanted to say, okay, how many cases will there be on day 50? All right, then what we're going to do is we're going to take our equation, y equals 721.9. Let's see, 721.9 times 50, day 50, minus 2,192.25. So that means that on day 50, there should be 33,900 cases of COVID-19 in the United States. Now, I have on here a graph, day 50. I don't even know if we're at day 50, but you can see it's pretty close to where it says. All right. You can also see that in the beginning, this kind of looked almost linear right in this area, and then it's leveled off as it goes down. All right, I hope that that made some sense. It's kind of a weird topic, but I think that it's actually really cool. So I hope that you enjoyed. We are going to talk in the next video about quadratic regression and what that would look like. All right, bye.